Fine. Good morning, all. So today we will discuss about the resistors which are connected in series and parallel. Okay. So first we will see the resistors which are connected in series. Okay. So this is the series connection of resistors, and the definition is that a combination of two or more resistors which has one and only one path for the flow of current is called a series circuit. Okay. So it means there is a resistance 1, 2, 3, and they connected in series. Series connection is that the the flow of the current will have only single path. Okay. So it is called a series connection. It is called a series connection. So here we have connected three resistors, okay? Resistor R1, resistor R2, resistor R3, and this connection is called series connection. Here if we observe, the current flow path is only single path, okay? There is no direction of the current flowing to the any other branch. So here if we observe, the current flow will have only the single path, okay? So this type of connection is called a series connection. And here if we in a mathematical analysis consider three resistors R1, R2, R3 connected in series across a constant DC source voltage source as shown in the figure. If you observe in the figure, here we have to calculate the current. So first we will calculate the current. So it is in series, as this is a series circuit, the current flowing through the R1 and the current flowing to the R2 and current flowing through R3 are same because it is a single path. So the current I1 is equals to I2 is equals to I3, okay, which is equals to the total current I. So I1 will be equal to I2 equal to I3, which is equals to I. Okay. Now we have to find out the voltage. So how to find out the voltage? Here, as it is a resistance, there will be the voltage drop here. So at resistance 1, the voltage drop is V1, and at resistance 2, the voltage drop is V2, and at resistance 3, the voltage drop is V3. So we have to find out V1. So according to the Ohm's law, V1 is equals to I1 into R1. Okay, so we know that V is equals to I into R. So finding out of V1, so V1 is equals to I1 into R1. So V2 is equals to I2 into R2, and V3 is equals to I3 into R3. Okay. So, but we know already that I1 is equals to I according to the above formula. Okay. So I can directly substitute in place of I1, I2, I3, I value. Okay, so V1 is equals to I into R1, V2 is equals to I into R2, V3 is equals to I into R3 finally. Okay, so these the voltages will be different in the series connection. Okay, the voltages will be different in the series connection according to the resistance. Okay, and what is it? The total voltage in the series connection. So we have to find out the total voltage in the series connection. Here we know that I is equals to I1 is equals to I2 is equals to I3. This is a current. And the voltage, what is the total voltage V? So V is equals to, here the V is equals to V1 plus V2 plus V3. So V is equals to V1 plus V2 plus V3. Okay. Uh, so this is a voltage calculation. So now in the series we know that how to calculate current and voltage. Now we will calculate the total resistance. Okay. So this is a series connection. So example. Okay. So substituting the equation 1, 2, 3 in equation 4. So this is equation 1, equation 2, equation 3. We are substituting in equation 4. What is equation 4? Equation 4 is V is equals to V1 plus V2 plus V3. So what is V1? V1 is I1 in I into R1. V2 is I into R2. V3 is I into R3. Okay. So here I am taking it as common. So I into R1 plus R2 in R2 plus R3. Okay. So here V by I. V by I is nothing but I is equals to V by R. So R is equals to V by I. So this is a resistance. So capital V is a total voltage, capital I is a total current. So this representing the total resistance. So total resistance is equals to R1 plus R2 plus R3. So this means in series correction, the total resistance value will be addition of all resistors. Okay. So here we have three resistors. If we add these three resistors, we will get the total resistance. Okay. So R total is equals to R1 plus R2 plus R3. And power also we have to calculate. And the total resistance generally we will call it as equivalent resistance. Okay, that is a equivalent resistance. And power we have to calculate. So the total electric power supplied by the source in any series circuit is equal to the sum of the powers in each resistors in series. So the total power is sum of the powers which are in series. So the power at R1, the power at R2 and the power at R3. Okay. So P1, so we have to find P1, P2, P3. So what is P1? P1 will be V1 into I1, P2 will be V1 into I2, P3 will be P1 will be V1 into I1, P2 will be V2 into I2, P3 will be V3 into I3. Okay, this is how we have to calculate the total power. So this is all about the series connection. Okay. Okay, now we will see the parallel connection of resistors. Here we are considering the three resistors. How we will actually, we have a definition, the connection of the three resistors in parallel, that a combination of two or more resistors in which all of the resistors are getting the same voltage. Okay, getting the same voltage is called the parallel connection. Okay. So for series connection, the current will be same, and for parallel connection, the voltage will be same. So you have to remember this point. For series connection, current will be same. For parallel connection, voltage will be same. Okay. So from the definition, the voltage, the total voltage, the parallel circuit, the voltage is same for all the elements. So here at R1 we will get V1, at R2 we will get V2, at R3 we will get V3. Okay. So what will be the V1 value? V1 is equal to V2 is equals to V3, which is equals to the total voltage V. Okay. As it is parallel connection, all the voltages are equal. And yes, I can say that parallel connection is like that. The resistors, all the resistors, one of the end is connected to at one point, and other end of the resistors are connected to the other point. Okay, this I can say the parallel connection. So we know the voltage, now we have to find out the current. So what is the current? So here we have to calculate the current. So as if we observe, the current is flowing from this voltage to, there is now three different branches. So this current will divide it into three parts. Okay, according to the resistors. So here this is I1, I2 and I3, and again they will cross the resistors and they will join up, and it will flow back to the voltage. Okay. So here the division of current is taking place. So we have to find out what is the current values. So here, according to Ohm's law, the current through each resistor is given by, we know that I is equals to V by R according to Ohm's law. Okay. Likewise, we have to find out the I1. So I1 is equals to V1 by R1, which is equals V1 by R1. Likewise, I2 is equals to V2 by R2. I3 is equals to V3 by R3. Okay. So here we know that V1 is equals to V2 is equals to V3, which is equals to the total voltage. So in place of V1, V2, V3, I'm substituting the V value. Okay. So V1 is equals to V by R1, I2 is equals to V by R2, I3 is equals to V by R3. So this I am placing the equation 1, equation 2 and equation 3. So what is the current in a parallel connection? So from this only we can tell that I is equals to I1 plus I1 plus I2 plus I3. Okay. So I is equals to I1 plus I2 plus I3. So now in equation 4, I'm substituting the equation 1, 2, 3. So I know I is equals to I1 plus I2 plus I3. Even I know I1 value, I2 value, I3 value. I will directly substitute it. So I is equals to, in place of I1, that is V by R1 plus, in place of I2, V by R2 plus, in place of I3, V by R3. Okay, which is equals to, and here V I'm taking common and I'm sending down. So I by V, which is equals to 1 by RT. Okay, V by I is R, I by V is 1 by R. Okay, so this is total current and total voltage. So what we are getting here is the total resistance. Okay, so the total resistance is equals to, that is 1 by RT is equals to 1 by R1 plus 1 by R2 plus 1 by R3. So the total resistance, we have to find out RT value, not 1 by RT value. So RT value is equals to R1 plus R2 plus R3 divided by R1 into R2 plus R2 into R3 plus R3 into R1. Okay. So this is a total resistance formula when three resistors are connected in parallel, and this is also called as equivalent resistance. Okay, so now we got the total current value, total voltage value and total resistance value. Likewise, we have to find out the total power value also. So the total power value, that is the total power supplied to the by the source to the parallel circuit, is equal to P1 plus P2 plus P3. So individually we have to find out what is the P at R1, P at R2, power at R3. Okay, power consumed by R3, power consumed by R2, power consumed by R1, which is equals to V1 into I1, V2 into I2, V3 into I3. Okay, it is similar like a series. Okay, now we'll solve some problems on the series and parallel circuits. Okay, this will come for an examination. Fine, a series circuit, will take a series circuit here. When two resistors 10 ohms and 20 ohms are connected in series across a supply of 220 volts, determine the current flowing in each resistance and voltage drop across each resistance. Okay. So here what they are telling, that there is two resistors, that is 10 ohms and 20 ohms, which are connected in series and across a supply of 220 volts. See, uh, for every problem you have to draw a circuit diagram. Here the circuit diagram is not there, but you have to draw the circuit diagram also, which will help you for understanding. Okay, so there is you have to draw two resistors in series. Okay, and the two resistors, 1 second. Yes, so here we have to find out the current flowing through each resistor and the voltage drop across each resistor. So after drawing the circuit diagram, you could able to you could able to analyze the current flowing and the voltage drops also easily. See here, as this is a series circuit, that is 10 ohms and 20 ohms, the total resistance you can find out, the total resistance value is R is equals to R1 plus R2, which is equals to 10 ohms plus 20 ohms, which is equals to 30 ohms. So the total resistance is 30 ohms. Okay. So now you have to find out the current. So current, we know that it is a series circuit. So in the series circuit, I1 is equal, total I is equals to I1 plus I2. Okay, sorry, I1 is equals to I2. As it is a series circuit, the current flowing through the resistance 1 and through the resistance 2 will be same. So, the total I will be equal to I1 is equals to I2. So, we have to find out I, because and we know the total voltage V, which is given, that is 220 volts, and we know the total resistance R, that is 30 ohms. Now we can find out the total current according to Ohm's law. So I is equals to V by R, which is equals to 220 divided by 30, which is equals to 7.333 amps. So this is the total current. So what will be the current I1 and I2? In the series circuit, we know that I1 is equals to I2, so which is equals to 7.333 amps. Okay. And now we have to find out the voltage across 10 ohms. So what is the voltage across 10 ohms? That is V1 is equals to I1 into R1. Okay. So V1 is equals to I1 into R1. R1 is 10 ohms and I1 is nothing but I, that is 7.33 amps. So which is equals to 7.33 into 10, which is equals to 73.33 volts. Okay. Likewise, we have to calculate even the voltage across 20 ohms. So the voltage across 20 ohms is V2 is equals to I into 20, which is equals to 7.33 into 20, which is equals to 146.66 volts. So V1 value, what is the question? That we have to find out the currents flowing in each resistor and the voltage drops across each resistor. So the current is I1, I2 is equals to 7.33 amps. I1, I2 we got, and V1, V2 we have to find out. V1 also we got, and V1, V2 both we got. V1 is 73.33 and V2 is 146.66 volts. See, sometimes you people will get doubt whether whether you people have got V1 and V2 value correct or else not. So for this, you have to do one thing, that you can cross check your values, that by in a series connection, you people know that the total voltage V is equals to V1 plus V2. Okay. So you have to add V1 plus V2, which must be equal to the supply voltage, that is 220 volts. Okay. If V1 plus V2 is equal to supply voltage, then your answer is correct. So this is one way of cross checking your answers. Okay. So here now you people add 73.33 plus 146.66 volts, which will be equal to 220 volts. Okay. This is how you have to cross check the answer.